So my name is Benschop. I'm a molecular virologist working at the National Public Health Institute of the RIVM. I'm also involved with Heli Harvola and Thea Colton-Fisher in the ENPEN steering committee and working on enteroviruses in particular, and also paracoviruses, but also hepatitis B virus. So I'm going to see if I can share my slide. So yeah, I'm going to tell a bit about EVD68 in Europe based on studies we did within ENPEN. So a lot of this work is data from many ENPEN partners. So first I want to thank them all for contributing to these data that I'm going to present on behalf of them. First, to go back in time to give the data a bit of context in Europe. So this is a graph I made from all published studies from European data showing EVD68 cases reported. So you have you can roughly say there are 3 periods. We have a rare period, but I would say this period is where stool was mainly sent in for detection and typing. So this needs to be taken with a grain of salt. Then we had a period where there were a lot of respiratory outbreaks, and then from 2014 we started to see the AFM cases in Europe as well. This is a biannual scheme I adapted from Kevin Messakar, where he presented it really nicely a few years ago, showing the biannual cycle of enterovirus D68 circulation, having high years in even years and low circulation in the uneven years. And from 2014 to 2018, we see a similar picture as you have seen in the US, where the even years are high years. But in 2019, in Europe, we started to deviate from the US in that we started to already pick up EVD68 in 2019. It was still a bit lower than the other high years, but it was still there, so it was noticeable. And then in 2020, of course, COVID hit, and then in 2021 we saw a huge outbreak, which is in contrast to what is seen in the US, actually, where you didn't see any enterovirus D68. And in 2022. Again, different. We don't, well, we've seen enterovirus D68 circulation, but that's not as high as the peak years that we've seen them. So a bit about the outbreak in 2021, to take you back a bit, we collected the data from 19 European countries from 58 partners within ENPEN, and they have tested about over 150,000 samples, and over 10,000 of them were EV positive, and of those 1,004 were EVD6 positive samples. From these samples, 940 cases were reported to us with clinical data from 2021, and in 2022 we had 29 cases, but these are mostly cases in January, so lingering on from that outbreak. And in this study, we collected demographic data, clinical data, and sequence data, and this is a bit to show how the epidemiology was in 2021. And this is roughly where most European countries started easing their lockdown measures. So it coincided with the ease of the lockdown measures. And then we had a huge upsurge in enterovirus testing, enterovirus positivity, but also the major type that was then found was enterovirus D68 in most European countries. We did have a few countries that didn't report any EVD68, I should note that. So children were mostly 2 to 5 years old, and also seen in other years, respiratory and fever was reported predominantly. Neurological reports were also reported, and we had 6 AFM cases reported to us in 2021. So as I said, we gathered phylogenetic data, and as you can see here, so this is the phylogenetic tree made by Peter Simmonds, and this is then the phylogenetic tree made by Emma Hodcroft from NextStrain. And so here depicted are the outbreak or the high circulation years with 2019, a bit higher. And what we see is that there is the circulation of the what we call the A2D clade and a B3 lineage that is continuously evolving in a step ladder-like evolution. We also see lineages coming up, but also the lineages disappearing again. And in 2021, we saw a new lineage appear as well. Whether this lineage will continue in 2022, we've not investigated that yet. So going on to 2022, so this is data that we gathered in an informal manner. We made a simple report about this, and this was based on a report that you in the US reported. So we started looking in Europe whether we also would see EVD68 in the fall of 2022. And there were some reports of enterovirus D68, mostly reported B3, mostly children, and again hospitalized with severe respiratory symptoms. But this was not as high, as I said, in the peak years. What was interesting to note is that we did see, even though it was a low circulating year, we did see 8 AFM cases in 4 countries. 3 of these were D68, 1 was an A71, and the other were untyped, but one had a severe asthma with an EV diagnosis a week before. There was also a report of a D68 fatal case, but the cause of this is not clear, and an epilepsy case, and also one that had cerebral paralysis, but was not typed at that time. So this is a map courtesy from Jelte, who also presented this, I think, in another meeting also here. And these are the countries that reported EVD68 circulation. They did see some peaks, but as I said, not as high as the other years. And here you can see where the cases of AFM were reported. So in 2019, I didn't mention it, we had a report of 2 AFM cases, but these were the cases that reported to us to ENPEN. So this is probably an underreporting. And then in 2021, as I said, we had 6 cases reported that we are going to publish soon or submit the paper soon. But thanks to the work from Jelte, we know that there were 20 AFM cases reported in Europe in 2021 in that year. Not all of them were enterovirus D68. A lot of them were also not typed. And then in 2022, we had the 8 cases, even though it was a low year. So yeah, Europe is kind of shifting from the US data in the sense that the circulation is shifting to the even years being low years. We don't know what is going to happen in 2023. So we are vigilant in what is going on. We haven't seen any virus or any reports from our ENPEN colleagues on enterovirus D68 high circulation in that sense yet. So yeah, and I'd like to give the floor to Peter, who will go on to the more genetics of this of the circulation in Europe. Peter, stop sharing.
Thank you so much, Kim. This is a quite amazing amount of information, and thank you, Peter, for that work. Any question from the group for Kim? Is there any data on when you mentioned in the cases that you are putting together for publication, you mentioned that some of them are not necessarily ED68. Do you have any idea what virus is involved?
Of the AFM cases?
Yeah.
I mean?
In 2021, I'm sorry.
Yeah, we I had the data and Jelte also presented it. So it was various, most were enterovirus D68, and I can remember there was a Coxsackie B in there and also an echovirus, but I don't have the data on the top of my head, but there were various enteroviruses, but most D68.
Great, and Matt, you raise your hand.
Well, Bernardo beat me to it, so I'll let Bernardo go first.
I'm curious whether you've seen a difference in the seasonality of RSV in Europe. similar to what we've seen in the US?
Yes, we've seen for RSV at least. That's my colleague's work, Adam Meyer's work, but he's presented the data that the circulation has been different after the COVID-19 pandemic, and it hasn't been how to say it, restored in that sense.
Kim, what is the size of the population that ENPEN covers? I'm just curious because the raw numbers are always so much lower for AFM cases in Europe, but I think of the populations as similar, but I know the network isn't all encompassing.
The network is really it's growing, and we have now well, we are going to start one of the strands, a hospital-based surveillance strand, CNS strand. We've already started it, and we're going to also start a respiratory strand and a hand, foot, and mouth disease strand. And in those strands, we are going to collect catchment population data as well, so we have an idea of what these positive numbers are relating to. So I don't have that data right now, but we are planning to collect that data to get a better idea of what we are looking at.
Cool, thanks.
Can I add to that? Because I think you're also referring to the low number of AFM cases in Europe, and I think that also is well, due to it's informal reporting and not from every country. So like I mentioned before, in Europe we have gone mostly from the enterovirus D68 route, and not so much from the AFM route. So I think the number of cases is, well, largely an underestimation of the real number. And we know, for example, from the Netherlands, we know that we had 4 cases in 2021 in a small population. And well, I'm sure that there are more cases in Europe than 20 when what was in the presentation.
Gotcha. Thank you.
Peter?
Okay, thank you. Yes, I'll just share my screen. Okay, there you go. Okay, there's a very old slide. Can everyone see that? Ellie and Kim asked me just to talk a tiny bit about the genetics, and I was given 2 or 3 minutes, so I'm going to just whiz through a couple of slides, really just to show the sort of approaches that we might take in terms of looking for determinants of pathogenicity that might associate with changes in AFM prevalence in relation to infections. And just as a bit of background, obviously there has been a bit of mouse work or animal model work to try and look at determinants of neuropathogenicity and neuroinvasion and so on. And there's obviously the suggestion that it's linked to potential changes in receptor use. Although in these cases not clearly linked to changes in actual sequence in the P1 or structural gene regions. I'm just going to go back to that tree you saw earlier. So this is a sort of analysis of the complete genomes acquired for the ENPEN study and joined up with the published data sets. There's about 1,000 full genome sequences there. And I think the striking thing is obviously the emergence of B1 down at the bottom here, which kind of started around 2010, then diversified and became extinct. B2 similarly became extinct, and then all the forward evolution since then has been B3. And these are evolution distances, not temporal distances, but you can see there is a genuine diversification of viruses over the last 4 or 5 years. And there are these 2 new lineages that Kim mentioned that have actually gone quite a long way between 2019 and 2021 and 22. So there's been obviously quite a progression there. It would be very nice to try and map changes in pathogenicity to the various clades in this tree. But obviously there are sort of major hurdles with doing this. Well, I think we've all sort of made a bit of a start with this and collating data together. And in fact, this table on the right shows the sort of number of sequences we can analyze for the P1 region from ENPEN and from GenBank. I think we need to concentrate a bit more on getting full P1 and 5' UTR sequences. A lot of the work we did in the paper was a short region of VP1, so we're going to not necessarily find any determinants there. In terms of what you can do, we can look at site heterogeneity at each position in P1 to look at sort of fixation mutations that may be associated with changes in phenotype, and also evidence of positive selection at certain sites. And of course, those may be also related to antigenic change. I think one of the challenges is penetrance, in the sense that a particular mutation which perhaps changes receptor use and may be associated with a different clinical phenotype may be necessary for that change to occur, but it may not be sufficient, and there may also be host factors as well. So, you know, it's going to be quite loose when you start looking for changes like that for something that's a rare clinical outcome, and obviously people who may well have viruses capable of being pathogenic but actually don't have the right host background for it to be expressed. So I think we have to bear that in mind, and penetrance is obviously a very difficult issue. And of course, the other thing we'd like to do is try and map all this to the experimental data that's been acquired from mouse models and so on. So just at a very preliminary level, we've been looking at some of the fixed changes and site heterogeneity in B1. And so these are collections of sequences pre-2014 and in 2014. And the little depiction of grey bars at the top shows that actually the consensus sequences of the two time periods was the same, apart from two fixed mutations at 746 and 770. And those actually associate with sites that are quite heterogeneous. So this bottom graph shows site heterogeneity in prefixation. So we can look at that, and in fact you can do a further analysis. So this is of B3 and the variants that have emerged in the last 2 years in 2021 and 22. And you can see that there has been a bit more fixation of changes, and obviously, you know, if you wanted to, you could try and use those years to associate with AFM potentially. Obviously, the difficulty is that we don't have a lot of data from a lot of the sequences on what the clinical phenotypes were, but I think, you know, obviously there's a chance we can go back through the ENPEN data and actually get P1 sequences specifically acquired from AFM cases that have been reported, so we can actually sharpen up the analysis a bit. But obviously that's work to come. But clearly there are a lot of changes occurring between 2016 and 2018, and then very interestingly, in looking at some very recent sequences in 2022, there's been two further changes actually in the B3 lineage 1, which is outgrowth of sequences. So obviously those phenotypes may well be interesting and relevant. Okay, so just like thank everyone, and I'm sorry it's a bit preliminary, and also not worth more than 3 minutes presenting, so thanks.
Thank you, Peter. This is very interesting. I'm very sure that there are more questions about this. So open the microphone to the group if there are more questions. Brian, Daniel?
That was really interesting. I'm guessing it's a bit tricky to work it out, but do you have any feel for if viral genotype affects transmissibility?
Yes. Well, that's sort of interesting. Actually, I didn't show. When I was told that I had 3 minutes, I took out all the seroepidemiology slides, but we had done a previous study on looking at age-related seroprevalence of D68, and through modelling done in collaboration with Imperial, with Nick Grassley's group, we can show that there was a change in transmissibility around about 2012, which best accounts for the increased seroprevalence in young children in 2016. So, I mean, that's quite, I mean, that's not my work specifically, but it looks quite convincing that there's been a change. Of course, that's obviously different from the kind of AFM associations that occurred later on in 2014, 2016.